So we'll just wait here a little bit while so that everybody can join it. Hello Kapil. If you have any questions from yesterday, as again, please do not hesitate to ask them right away. And please like the video. Thank you.
Here is some.
Right. Let's see if anybody else joins in. Alrighty then. So I believe we can start the class. Let's start it. Alright. Okay. Cool. Okay, Kapil, is the sound clear now? Can you hear me properly? Is it audible now? All right, great then. Thanks. So we'll begin the lecture now. So today, as you can see on the screen, we're going to start with the contents for the course will be classes and objects, constructors, inheritance, visibility modifiers, and data classes. So all of this is related to OOPS concepts. So today is the OOPS part 1, and tomorrow we will see abstract classes, interfaces, and sealed class. So this is an extra thing over here which we can see while we are at OOPS concept. So today we'll talk about first thing will be classes and inheritance. So here's a basic simple program, just a normal Kotlin file. This is not a class file. So I'll go ahead and open the project structure here. So in the src directory, in the OOP project package, I have created a class, file named as live Kotlin oops concepts 1.kt. It's just a normal Kotlin file. It's not a class file. So let's try to create a new class. So you can create a Kotlin file class like this. Either you can choose it to be a class or an object, interface, or a file. But I just go ahead and type in the name of the file and create a file. Okay, so let's shut it down for now. So this is just a normal KD file, not a fancy class. So the way we create class is using the class keyword, and we use the class keyword and type in the name of the class. So let's call our class a person, and then this is the syntax of a very simple as short class can be, and we can even go ahead and remove this since this class is empty. So this is a class named as person which is doing nothing at all. So let's give it some functionality. So this is the primary constructor basically, and it doesn't have any values as of now. So let's go ahead and give this primary constructor some value. So basically the primary constructor cannot contain any code, but it can contain only the parameters or the variables. So let's say that this person has some name, okay, and string. So this name is type string, and this is the primary constructor basically. All right. So we also have an init block in Kotlin class. So init block is basically becomes a part of your primary constructors part, which the code is executed while we're creating the object of the class, so that this can be used to initialize some important data in your class. So let's go ahead and initialize the name in this class, and let's call it Kapil. Okay, so here let's see what's the issue. Val cannot be reassigned. In that case, we can specifically name it as Bob. I mean a variable. So by default, if you don't specify anything, it will be a val, in which case we will not be able to change the value. So let's use it as a var. And we can define some properties such as age, let's say age here, which will be of type integer. And by default, the age for the person will be 0. All right then. Cool. And by default, we can also do something like this, that we can by default give it a name, and let's say I give it the name as person, and we can choose to have any other name. So let's remove this line for now, and the by default name would be person for this class. And here we can do some initialization stuff, and we can prepare our class, prepare our objects for later use in our different methods. So initialization stuff will go here, and I'll just print a normal println statement here, initializing class person. Okay, so that makes sense. Okay then. So this is basically a primary constructor which has one single argument, and we have a field here, in the name of age, and we have an initialization block here. So I think we are pretty good. Okay, for now, let's try to create an object for this class person, and we have to pass in the name. Let's call this name as Kapil. And if you don't pass any name, the name would be by default person. So initializing class person, and we can print in the name here, and person, the name is $symbol name. Okay, let's run this program. So the name is Kapil, and even if I don't pass any name here, let's keep it empty. Since we have a by default name here, which is like just similar to what we saw in the functions class, like a named argument, like a default argument. So it will work like that. Let's run this. So the by default name would be person. Okay, so fair enough. Let's go further, and let's also display the age now, and age is $symbol age. Okay, let's remove person from here. Let's not make the string too big. Initializing, the name is this and the age is this. Okay, cool. So let's create a secondary constructor from now. So before that, if we have to like let's say in Android, you're using something like Dagger, where you are initializing your classes through Dagger, and you're injecting that class, where you have to use some kind of annotations. In that case, you have to specifically write the constructor keyword, constructor, and in that case you can use the annotations in front of it. So this annotation is coming from Dagger, let's say, in Android, and this is the constructor keyword. So here we don't have it. That is why we are not using the constructor. We are not explicitly typing constructor here. but if you want to have it, you can add it as well. If you want to remove it, you can remove it as well. So let's have it for now and just keep it there, but it's not really necessary. So let's try to create a secondary constructor here. And a secondary constructor is basically like if a class is having a primary constructor, then the secondary constructors need to be delegated to the primary constructor by using this keyword, and I'll just show you how to do that. So let's create the secondary constructor here and type in the name here as well, string. So now this secondary constructor has to make a call to the not exactly a call, it has to delegate to the primary constructor as well. So we do it using this keyword and we pass the same arguments as the primary constructor, like that. So let's print a statement here. Secondary constructor name is this and age is this. Okay, so as you all know, the primary constructor does not have any body, but you can use the initialization part as the body, because at the end initialization part is kind of also executed when the primary constructor is being called. So that's the important thing to keep in mind, that the init block will be effectively becoming a part of the primary constructor. So let's go ahead and make a call to secondary constructor here. We pass in the age as let's say 27 and the name as, what do we pass in here? Let's correct. All right, so let's see what happens. So right now what was happening, we just made a call to the primary constructor, which is also executing the init part. We can see it here, the println statements are getting printed. So let's call the secondary constructor as well. Let's run this program. So here, this is the initialization part of the primary constructor, and then the initialization block is run again when we are calling the secondary constructor. So, and then the secondary constructor is getting called. Alright, so let me just write an empty println statement here to make it a little bit more clear. So this initialization block is when we call the primary constructor, and this initialization block here is from the secondary constructor, but because it's also delegating to the primary constructor. So that is why we're getting the init block is being executed again. Alright, so this is it for the constructors in primary and secondary. And we can also, so by default, all the classes are public and final in nature. Okay, before jumping to that, let me just have a look if anybody of you is having any questions. Alright, so nothing as of now. Let's keep going further. Okay, so all Kotlin classes are public and final in nature, so which means that by default this class is public and this constructor is public. So which is the reason why I'm able to I'll be able to create an object of this class from anywhere throughout this project. So anywhere I can go in and create a class, create the object of this class person. So okay, let's try to see if I make it as private. So now I have made the primary constructor as private, which is the reason why you can see here that we have an error, cannot access the init property, it is private in person. So that is the reason, but nothing changed to the secondary constructor as it is still public. So by default the visibility is public for this. And What if I make it private as well? In that case, we will not be able to access this. All right. So this is the way you can add the access or the visibility modifier to a class constructor. Prob- So we'll have a look at the visibility modifiers in the later part. After inheritance, we have covered classes and objects and constructors. So let's keep moving forward. So let's try to extend this class or inherit this class from another class. So we'll say class, let's say user, and the user is extending class person. And I define a body here. So now we get a bit of an error here which says that this type has a constructor and thus it must be initialized here. So which means that the user class will create a primary constructor in user, the same as in our base class or as in our super class, and we'll pass the value here. Okay, this type is final, so it cannot be inherited from. So now this is another error. So it is also suggesting us to make the class as open, which means that since all the classes are public and final, since this class is final in nature, I cannot extend this class. So I need to make this class open. So now it means that I will be able to extend this class. Okay, so now we have a primary constructor for user, and let me create an initialization block here and write a normal println statement. Init block of user. Okay, so all good so far. Let's try to create a new user, give it a name as something John, and let's run this. So let's see what happens. So we get initialization block of user. So the init block of user is printed. So let me just go ahead and copy this, paste here, just to have some clarity. Okay, so now let's try to override some properties of the parent class. So we have a property here which is called as age, and we need to access it in the user. So let's try to override. So we cannot override this as of yet because again this is also final in nature, we cannot override it. So again we'll have to just write open, and now this age will be available to override. So you can see this now, and you can just use this functionality to create a variable. So this is the way we are setting the getter and the setters on this, but we don't really need it. So this is, I'll explain you what exactly this is. So this is, we are just setting up some value for age, and this is a getter method for this property age. So which is initializing it to by default to the value of the parent class and accessing it using super. So we don't need this, and we'll give it our own default value that by default the user will have an age of 0, and it can be anything based upon your use case. Alright, so this is the way we are overriding a field or overriding property. Okay, it's really bad with spelling over here right now. Over. Okay, good so far. Alright, so let's try to create some method here, and we create method using fun keyword, and let's say that the person can play piano, and just write normal println statement here, playing piano. Person is playing piano, and now we need to override this method over here. so we cannot override it as of yet until unless we declare it as open. So now we'll be able to override play piano method, and you can choose to have a call to the super or not depending upon your use case again, but it's good to have to call the parent class method for now. So let's go ahead and just change this to user, and let's go ahead and call the method play piano. So now what will happen is that first of all the initialization block will be executed for this class user, and using the primary constructor a new object of user class will be created, and then after that we are calling the play piano method over here, which will first of all make a call to the superclass, which is basically the parent class, that is person, which we have defined here using this uh, symbol, and it will print this line first, person is playing piano, and then the user is playing piano. So let's run this program. It's pretty simple and straightforward as of now. So initializing the names John and age, which is basically here, because we have created a person, username is John, which is also making a call to the because of this. So why are we seeing the initialization block of the person class here? Which is because we are delegating here, we are making the call to the basically the primary constructor of the parent class. That is the reason we can see the initialization block of the person class, because when we create an object of user, the object of person class also has to be created. So, and then the initialization block of the user class, and then we have the super method dot play piano calling the parent class play piano, and then we have the user dot play piano. This is completely option for you, which is depending completely on your use case. So let's comment this and run this, and we will see that now the person is not playing piano, only the part the user is playing it. So I'll uncomment it for now, just leave it over here. And again, this constructor keyword is to declare the primary constructor. It's not really necessary. We haven't really used it here in the user. We can use it here, but it serves no purpose as of now, because it's only necessary to be used if we are using any kind of annotations. Like in Android, you use inject annotation to create an object of it using the dagger class or the dagger API. So in which case we have to explicitly define the constructor keyword. Alright, so let's see if anybody has any questions. So all going okay for so far. Okay, so this is the way we have covered inheritance, constructors, and classes and objects. Let's jump on to visibility modifiers. So there are basically four kinds of visibility modifiers in Kotlin. Let me just write them for you. Modifiers. So the first one if then is public, which we have already seen that all the Kotlin classes, okay, there's a spelling mistake here, sorry. All the Kotlin classes are public and final in nature. So all the classes are by default public. So even if we write public in front of this, it will make no sense, and even the Kotlin compiler will suggest us that this public is redundant, it's not required. So it will ask us to remove this redundant modifier, because by default this class is known as public. And the same goes for this class as well, but since we have this class open now, so yep. Right, and second is private. Private means that okay, let me just write down here everything, and then I'll explain it to you. The fourth is protected. And if we go from like tightening the security, private will come last, then we'll have protected, then internal, and then private. So this is the actual hierarchy like this. So private is more strict, internal is lesser strict, protected is more less strict, and public is kind of totally free. You can access it anywhere. So by default we have the public access, and we can choose to have restrict the access. Okay, so public will mean that you have access it everywhere, which we have seen. Right, and protected will mean that you can use it in the nested classes or subclasses, like the child classes or whatever you like to call them. So let's say we have this property as protected, and let's see, can we access it over here or not? So we can definitely access it in the non-canonical modifiers order. Let's move this here. Let's try to put it here. Okay, so even Kotlin is kind of suggesting us that the visibility modifier comes first and then this open keyword. All right, cool. So if we have the video age as protected, we can definitely access it over here. Let's make this function as protected, and still we can make a call to the function here, play piano, but let's change it to private and see what happens. So now we cannot call this method super.playPiano because this method is now private, and private method is incompatible with open, which goes by default that if we want this method to be private, then we definitely don't want this method to be overridden at all in the first place. So that is the reason open doesn't make any sense here. So remove the private right now. And that's just to give an example that with private you cannot access it in the subclass or the child class, but if it is protected, you can still access it in the subclass. So that's about protected. Internal means that you can access it inside the module. So now a module refers to a bunch of Kotlin classes, like here is a project. So first is a module. This is basically the project that I created. This is a module. Your project can be a multi-module project where you will have the same structure again, like you have another src, another bunch of files. So usually in Android projects, you use multiple module projects for higher complexity projects. So in that case, if you want your class or your method or your property to be accessible within that module and not to some other module, in that case you can choose to have internal access. All right, and private you mean only within the same class or whichever scope you have declared it in. All right, so this is basically it for visibility modifiers. And let's see why we're getting a red error here. That is basically because cannot access play piano, it is protected in user. So which means that I cannot access this protected method outside of the scope. The scope is only in the subclasses and the child classes, which is this area only, so I cannot access it here. So let's change it back to open and public. All right, all good. So now let's jump on to data classes. Data classes, as they suggest, are something which we use to hold the data, and they're also like a very important aspect, and you'll use them a lot if you're developing Android applications, and it's really beneficial and makes your code really short. And I'll also give you a live example of how short your code becomes from Java to Kotlin by using a data class. So let me just explain you the syntax first. So data classes can be declared using the data keyword and then adding the class keyword next to them. So let's say I'm creating a data class named as um, some data which is coming over the internet. Let's say um, shape. Let's say it's called a shape. Alright. So here I will declare some values in the constructor. Let's say the name of the shape, which is type string. And then I can give it how many sides does this shape have. Sides, which is a type of integer. And you can see that here I used a val keyword and here I have not used a val keyword, so it's giving me an error here which suggests that which is pointing to one of the property of the data class, that the all the primary all the primary constructor parameters need to be marked as either val or var. So you can choose it to be either val or a var. So if I don't declare any of them, it doesn't mean that by default it will be val. It is necessary for me to define that. Okay, so let's have only these two parameters as of now. And let's take another example to create another kind of data class, which is employee. So now employee will have a name, employee will have an ID, and employee will have a salary. Okay, and again here we can provide some by default data, that if there is no ID provided to the user by default, the ID will be 0, which is a bad case if example, because ID should be unique. So let me just remove this. Let's say that the by default name should be employee. So you can choose to do that as well. So which is depending totally upon your use case and what you want to do with it. Okay, so this is something which you can do. I'm just removing it for now because I don't see any effect. Okay, so this is the basically just one single line of code which will generate a lot of methods for you, because a data class is basically similar to what you used to have Pojo classes in Java, but with a lot of functionality as well. And we'll see that in just in a moment, but before that we just need to cover up a few important points. That the main purpose of the data class is to hold data and pass data around, either getting it from the network or from the database and passing it around different activities in your Android project or different places. And the data class cannot be abstract or open or sealed, or it cannot be declared as an inner class as well. So I cannot make this class as an abstract class, which is completely wrong. It goes against the rules of a data class. You can see modified data is incompatible with abstract. So we'll see abstract classes and interfaces tomorrow. And for now, let's okay. And yeah, so the last point is that the primary constructor needs to have at least one parameter. So if I'm creating a data class here, let's say something which holds data, and I cannot just leave it like that. You'll see that there's an error over here, and it says data class must have at least one primary constructor parameter. So if I give it some parameter, let's say a integer, now the error is gone and I have a data class, which also makes sense because the Pojo class has to have some kind of properties in it which will generate the getters and the setters method. Okay, so now let me just copy some code from the internet. So this is an example I'm just copying from some website which has created a Pojo class in Java. Let me just copy it. All right, cool. So I've copied it and I'm gonna paste it here. Let me paste it. So you can see that I've pasted it here and it's quite a big file, which is nothing but a Pojo file, and it is telling me that it has some salary, it has a constructor public employee with name, ID, and salary. Sorry, I can't scroll at the moment because otherwise this uh, will go away. So just that the class has a name of employee and it has some fields like salary, age, and ID, and it has a a public constructor, and it has some getter and some setter methods. All right, so let me convert this code to Kotlin because by default the IDE gives me this option that if I'm copying and pasting some Java code in it, it will detect it and it will convert it to Kotlin by default. So even the Android Studio is also based on IntelliJ IDE ID, so it also has this feature. So let me press yes, and all the big chunk of code is converted into a simple small piece of code with the same functionality, and all that we have to do is just add data in front of it. So that's it. So let me remove all these comments which don't make any sense right now. Okay, so that is just gonna be converted into a single line of code, which we were doing it in like a long manner in Java. So this is converted to basically a simple Pojo, like a simple Pojo class has been converted to a data class in Kotlin. So that is it. And you can create an object of this data class and initialize it here. This, and pass in some values like, so what exactly are the values here? For shape, it's the name and the number of sides it has. Let's say the name is rectangle and the number of sides it has is 4. So now if I just go ahead and print this line, print this object, the by default the toString method is overridden into this class, which will be called, and it will print all the values of the data class object, which was a functionality we had to override in Java, and then yeah, Kotlin makes it really simple. So it just has a toString function which is overridden, and it is converting this object into a string by default for us, and it is printing the name, the sides, all the parameters. So if I go ahead and by default call that toString method, so it is not really necessary to call it because by default it will be called. So let's see what exactly is the toString method. Let's try to see if we can find that data class. Okay, I'm not able to find a way to go to the declaration, but yeah, so all the methods are being generated automatically, which is one of the method is toString, another method is hash code. So these methods are generated automatically, and there is one more method. I can't remember it right now. I think it is compare, I guess. I'm not sure at the moment, but I believe it to be compared. So let me remove it for now. So these methods, getters, and setters will already be generated for these parameters, and you define it in a constructor. So this is basically a constructor, and you can choose to add a constructor keyword in front of it as well if you are having any annotation or something, then it makes sense. Otherwise you can remove it as well. So it is basically a primary constructor. All right, so this is basically it for the course content for today, the OOPS lecture. And if you have any comments or questions, please let me know. Okay, I think we're going good so far. So that is it, guys. Thank you so much for watching this video. If this has really helped you in some way, please do like, share, and comment on this video. It will mean a lot to me. Thank you so much, and I will see you tomorrow in the next video where I will tell you about the abstract classes and interfaces, and I will give you some really cool examples of creating an abstract class and creating an interface, and some real time examples of how are they being used as an important aspect of creating some good and valuable code which is maintainable in future. So good luck, guys. I'll see you in the next video soon. Thanks. Bye bye.